Next thing that we want to take a look at is how do we solve using right angle trigonometry for an unknown angle. Okay, so we've talked about how to solve for an unknown side. Now we're going to talk about how to solve for an unknown angle. So let's say, for example, that we've got a triangle, and our triangle is labeled looks like that, and we don't know what this angle is right here. So angle X. We're going to call this piece here uh, 15 units long. We'll say that this section here is 20 units long. We got to figure out what angle X is. Okay. So just as we've always done, better put that 90-degree thing there. So just like we've always done, first thing you want to do is label the HOA. So which is the opposite? The hypotenuse. That's our hypotenuse. We know that this is therefore the H value. We want to identify the side that's opposite. Okay, so the opposite side from the angle, that's our O, and therefore our A value is going to be this 15. Okay, so A is equal to 15. So now that we've identified all of those pieces, we have to figure out, well, which of the three primary trig ratios do you need to use? So just like we've done with solving for an unknown side length, we're going to write out SOHCAHTOA. Okay, so now that we've got our SOHCAHTOA piece, what we're going to do is identify what is it that we're looking for. And in this case, we're looking for the angle. The angle is always represented by the S, the C, the T, the sine, cosine, or tan. That's what we don't know. What do we know? Well, we have a value for the hypotenuse, so we can put a check mark above the hypotenuse. Okay, and we also know the value of the adjacent side length. Okay, and so based on this, we know that tan is not going to give us what we need. We don't have enough information, so we can't use tan. And sine does not have enough information for what we need, so we have to end up using the cosine ratio. Okay, so if we're going to use our cosine ratio, let's write out what that ratio is. So we know that cos of any angle is equal to the adjacent divided by the hypotenuse. So now that we've identified what the cosine ratio is, we're going to substitute in the values that we already know. So cos of x, because we don't know what the value of the angle is, and A is going to be 15, and that's going to be divided by 20, because the hypotenuse is 20 units long. So if I want to solve for this, I would simplify that fraction. I'm going to do 15 divided by 20, so cos of x is equal to 15 divided by 20, which is going to give me 0.75. And whenever you're dividing a fraction in the trigonometry unit, you should always go to 4 decimal places. In this case, it would be 0.7500. So I'm just going to simplify it to 0.75. So now I need to get that x value all by itself. And to do that, I need to use the opposite operation of cos. So I'm going to do x is equal to cos -1 times, or rather the cos of, the inverse cos of 0.75. Okay, so my final value, if I put in inverse cos 0.75, that spits out for me 46 degrees. Okay, so that is one example of how to solve for an unknown angle. Okay, and that process is going to be the same all the way across. So let's try a second example of that process. In this case, we've got, again, another triangle. Now we don't know this value, so this is going to be our x value. And we know that this side is going to be 10, and this side is going to be 7. So again, the first thing that we need to do if we want to solve for this, we have to label our HOA. And again, let's just quickly make sure that we've identified that this is the right angle. So our HOA, we've got our hypotenuse. We also therefore have our opposite side. Okay, so our opposite side is right here. And that means by default that the 10 is on the adjacent side. So let's go through and let's identify our SOHCAHTOA. SOHCAHTOA. And so in this case, we are looking for the unknown angle. So I'm going to underline the S, C, and the T because that indicates what I'm looking for. Let's identify what I actually have. So I know that I've got the opposite. And I also know that I have an adjacent value. Okay. And so the only one of those three ratios that has the thing I'm looking for, the unknown angle, and two pieces of information is tan. So I have to use the tangent ratio. So I'm going to use my tangent ratio. And so the tangent ratio is tan theta, or tan of any angle, is equal to the opposite divided by the adjacent. So now I'll substitute in the values that I need. So tan of x, because I don't know what the value of the angle is, that's what I'm trying to solve, is equal to 7 over 10. Okay, so now, just like I did in the last time, I'm going to simplify the right-hand side of this equation. I can do 7 divided by 10. So I've got tan of x is going to equal 0.7. If I went all the way to 4 decimals, it would be 0.7000. And now I want to get that x all by itself, so I got to deal with that tan. And the way to get rid of tan is to use the inverse. So we're going to do tan negative 1, 0.7. So in my calculator, what I need to do is I put in shift tan to get the tan inverse sign, and then 0.7, and then I hit equal, and then that gives me approximately 39 degrees. And it's very important to put in the degree sign, because if you don't, you're going to have the wrong final answer. Actually, now that I'm thinking about it, it's also very important to make sure that your calculator is in degree mode, because mine was actually just in gradient mode, and it gave me the wrong answer. So it should be, whoops, 35 degrees. Okay, so that is how you go by to solve for an unknown angle using the primary trig ratios.